Throughout its long history, the River Thames has carried the ships of the world to and from the Port of London. Nothing has been allowed to interfere with the free passage of those ships on their lawful occasions. And so, when the Central Electricity Generating Board decided that a new high-voltage transmission line must cross the Thames, here at Fiddler's Reach, 18 miles east of London, a first problem was posed: how to achieve the crossing without disturbing the shipping. The link was necessary because of the growing demand for electricity in southeast England. To meet the demand, the supergrid was to be drastically extended and a permanent link made with the power cables under the channel to France. Two ways were open: under the wide stretch of busy waterway, or 250 feet above it, out of reach of the largest ship. Here at Dagenham, a few miles upriver, a similar problem on a smaller scale was met with conspicuous success 30 years before. So it was fitting that the construction company which had made this earlier link was asked by the Electricity Board to plan a new one, a double-circuit overhead transmission line which was to become a landmark in British engineering. It soon became apparent that many problems would arise from the increased size of the new project. The suspension towers were nearly 150 feet taller than those at Dagenham. The conductors were to be more than twice the diameter, and the voltage 400,000 instead of 132,000 as at Dagenham. Height above the water was still to be 250 feet, but with each conductor weighing more than 21 tons, enormous tensions were involved. Here can be seen the difference in size between the new aluminium and steel conductor and the bronze alloy one used for the Dagenham crossing. Our final problem was the contract condition that these massive conductors must not touch land or water during the stringing. That last headache was left for the engineers to solve, while the site was cleared and work begun on the foundations for the two suspension towers and the anchor towers. The banks of the Thames here are marshy. This meant that the foundations for the 630 feet high towers had to be deep, with reinforced concrete piles driven down 40 feet and more. When the foundations were complete, slates and bolts were embedded in the concrete, ready to receive the tower legs. Accuracy here was of the utmost importance. Only when the engineers were satisfied was a tower leg lowered and bolted into place. All four towers were aligned to within a quarter of an inch. A novel feature of each suspension tower was this central column. Later destined to act as a maintenance shaft clear up to the 375-foot level, it served during construction to carry the derrick that lifted the outer panels. The steelwork for these panels was bolted together on the ground into convenient sections before being hoisted into position by power winches. Incidentally, bolts were used throughout construction, some 125,000 of them, and all bolts and steel members were galvanized, a very necessary protection in this district of salt winds and industrial air pollution. To give some idea of the size of the job which these men were tackling, this bottom panel alone, when completed, weighed 70 tons together with the base plates, and that is nearly 7 times the total weight of a standard supergrid tower. Panel by panel, the tower rose in a remarkably short time. In fact, a gang of only 10 men put up the first 300 feet, weighing 250 tons, in 3 months. They may look casual, but in reality they worked together in a closely knit team, relying on each other implicitly. It's a tribute to their skill and teamwork that the whole project was finally completed ahead of schedule and without a single casualty. While the towers were rising, we went further afield to watch another vital part of the operation, the making of the insulators. There was no mass production here. Each porcelain unit was fashioned by skilled craftsmen as carefully as the china on our tables. After each unit was shaped, it was dipped in glaze, then stacked for baking in the ovens, and finally electrically tested. These porcelain units then had to be assembled in strings. A A complete assembly for the suspension tower weighs 3 tons, with a braking strength of 94 tons, while those for the anchor towers, which have to take the full tension of the conductors, have a braking strength of 150 tons. Before being passed for duty, a complete assembly is taken to the laboratory and given a flashover test. And finally, the strings were packaged for dispatch to the site where they were reassembled ready for installation. Meanwhile, the towers were rising towards their full height. Whenever the weather permitted, men worked from early morning to dusk, 7 days a week. The higher the tower grew, the tougher their job. Once above the maintenance platform, the derrick had to be floated on steel wire ropes secured to the corner legs of the towers. Close cooperation between the winchmen on the ground and the men high up on the towers became even more important. Most awkward and seemingly hazardous operation was the erection of the top maintenance crossarms, 75 feet long and 615 feet above the Thames, with scarcely any visible means of support. And with the wind whistling through the structure, the crossarm was built up section by section. Only when it was complete could it be used to hoist the suspension tower insulators into position ready to receive the conductors. Those all-important conductors. When you set out to make something that has not been made before, you must expect some problems. To begin with, they were to be the largest of their kind ever used on an overhead transmission line of the British supergrid, being 2¼ inches in diameter. Then, because of the long central span, they had to have immense tensile strength to limit sag. A section sample shows the makeup. Around a central steel wire were wound 5 layers of galvanized steel wires. As this strong steel core was wound at the factory, it was thoroughly coated with protective grease. Samples of wire were tested to breaking point in the laboratory, and further tests were made to ensure that the galvanizing was perfect. The next stage was to wind on 2 layers of aluminium wire around the steel core. Up to this point, the conductor was ridged, and it was decided to use a special segmental wire for the outer layer. This left a smooth surface so that wind resistance would be reduced to a minimum. Here measurements are being made during handling trials. Because the end clamps had to be fitted at the factory, the exact length of each conductor was calculated and then made to an accuracy of 1 foot in 7,754. As each conductor was completed, it was wound onto a special large drum, every layer carefully covered to avoid damage, and the 2-day-long journey to the Thames site began. In all, 9 conductors were made, to include 2 spares. All was now set for the most intricate part of the whole venture, the actual stringing of the conductors. With the help of this model, to check vital details, the engineers had perfected a method of stringing without the conductors touching land or water on their 1.5-mile journey. First, steel wire track and haulage ropes were to be laid on the river bed, and then winched up over the tops of all 4 towers. The fixed track rope was to support a free-running trolley clamped to the haulage rope above. The purpose of the trolley was to tow the conductor right through the system. At 80-foot intervals, the conductor would be supported by suspenders also running on the track rope and clamped to the haulage rope. Now the time had come to turn theory into practice. First, there was the simple business of paying out the track and haulage ropes across the river. Incidentally, getting them wet didn't matter. They were to be removed when the stringing was complete. Next, as planned, the ropes were passed over the 4 towers. The river was closed to traffic for a brief period at low water, and the track and haulage ropes were winched up into position. This, by the way, was the method used at Dagenham 30 years ago to raise the conductors themselves, but it didn't meet the present specifications. With the haulage and track ropes in position, the first conductor drum was backed up behind the north anchor tower, the conductor end was fastened to the haulage trolley, and the stringing was underway. As the conductor was drawn up towards the top of the first high tower, suspenders were fitted at 80-foot intervals. These suspenders had rubber-lined bobbins on which the conductor could rest without damage. They were also provided with a special flap to prevent the conductor re-engaging once it had been released. Up on the high tower, men were waiting as the conductor steadily mounted skywards. And on the ground, constant radio control of the operation was maintained by shortwave transmitters at strategic points. When the conductor reached the tower, it had to be fed through to the riverward side and rested on the rubber-lined sheaves of a cradle that was ready to receive it. The suspenders carrying the conductor up to the tower were removed and replaced ready for the river crossing, and the long journey across the main span was begun. The speed and skill of the men and the efficiency of the radio control can be judged from the fact that running speeds of 30 to 40 feet a minute were maintained as the conductor was hauled over. As the conductor end reached the second high tower, the main haulage trolley had to be removed. The trolley was then lifted off and taken to the other side of the tower. But first, the conductor had to be passed over the rubber-lined sheaves of the cradle and guided to the back of the tower. During this operation, immense care was taken to see that the conductor was not damaged in any way. And as the conductor was fed through the tower, suspender intervals were metered. To supplement the radio control, the men had their own signals to each other. Flags, hand signals, a whole ritual, meaningless to the uninitiated, but essential in these conditions where the howling of the wind and the noise of machinery drowned the human voice. Down now towards the ground and the second anchor tower. All this time the conductor was under light tension only, and the leading end was still 150 feet short of the anchor tower on the far side. To increase the tension, men, like spiders on a giant web, fastened the conductor end to a holding rope, removed the haulage tail, and attached permanent links and plates to the dead end clamp. Winches now took the strain. Tension was increased, and when the cradles on the suspension towers were raised, all the bobbins still supporting the conductor across the main span swung free. The conductor, supported at either end and still resting on the cradle, was lowered to its correct position. Armour rods were now wound round it as a protection. This was to ensure that it didn't chafe in the saddle that was to carry it under the insulator assembly. Meanwhile, at the anchor tower, the conductor was linked up to the tension insulator assembly. Between the insulators and the quadrant to which the dead end clamp was fastened, there were a series of sag adjusters. Following a last sag check and any necessary linkage adjustment, The men on the top of the tower were given the signal to transfer the armoured length of the conductor to the suspension saddle and link it to the bottom of the insulator assembly. Some idea of the size of these insulators and of their height above the ground can be seen. The men are quite unconcerned about the height and about the wind that whistles unceasingly around them. But this wind is responsible for a last refinement, the fitting of vibration dampers. The wind could set up dangerous oscillations in the 1.5 mile long conductor. 6 Stockbridge dampers were therefore placed at the end of each crossing span, with 4 at the anchor span end. 5 more times, another conductor was threaded from span to span with the same precision. The terms of the contract had been handsomely fulfilled, for not once had any of them touched land or water on their long journey. With the final stringing of the earth wire through the tops of the suspension towers and the removal of the track and haulage ropes, the whole complicated business was accomplished and the overhead transmission link across the Thames was successfully completed ahead of schedule. Already, it is a familiar landmark to the ships that pass along the famous waterway. And already, too, it is playing its full part in the world's largest supergrid under unified control. At present, it carries 275,000 volts. And these slender-looking conductors are ready and waiting for the voltage to be stepped up to 400,000 volts when the demand for increased power comes. They, and the towers that carry them, are a magnificent tribute to the engineers who conceived them and to the men who built them under the guidance of the British Insulated Calendars Construction Company.
.312 had since 1955 been the only UK low-bridge trolleybus to sport retrievers. The end came shortly before midnight on the 30th of June 1958, when the last trolleybus entered Hall Street Depot. The 7 operated the circle in the clockwise direction and the 8 anti-clockwise. Various short workings were numbered between 9 and 12. Journey time round the 8-mile circle, on average, 44 minutes. In their 31 years, the electric buses had run 51.5 million miles, carried in excess of 600 million passengers, and most importantly, always operated at a profit. Much of the town centre has altered beyond recognition since these scenes were filmed. For example, Griffin's on the corner of Westfield Street and Sefton Place was demolished in 1974. On the curve from Ormskirk Street into Bridge Street. These scenes were filmed variously between 1956 and 1958. Passengers for the circle would board outside the market. Passing an RT outside the Savoy Cinema, now demolished, whilst another trolley heads for the loading point. Turning into the busy shopping thoroughfare Liverpool Road, now bypassed by a dual carriageway. Tyrers was subsequently relocated and this building demolished. At the end of the in-town one-way loop, 376 accelerates smartly up Cropper Hill. approaching the circle junction at Toll Bar. Whilst turning into St Helens Road, 376 clicks through the Frog for the Toll Bar turning circle. Inbound from Rain Hill, 384, resplendent with its corporation coat of arms, crests Lugsmore Lane and turns towards town. Following the clockwise 7, heading for Prescot via Rain Hill. Short working Saturdays only 9s worked to and from Prescot via Rain Hill. Sharing this section was bus route 24 to Sutton Manor. An inbound 8 tackles the grade up to Toll Bar. Looking across Lugsmore Lane Dam. This old humpback bridge at Fatto Heath Station has since been replaced. The turning circle at Rain Hill was still regularly used. The huge hospital complex, together with its boundary wall, would later be demolished. Already in position, one of the new bus stops. Housing estates now cover these fields at Rain Hill Village. Passing outside the Coach and Horses, Rain Hill. On busy Warrington Road, a Crossville low-decker heads for Warrington as an anti-clockwise 8 turns towards Rain Hill. Wiston Hospital. On the outskirts of the small industrial town of Prescot. Having terminated in Prescot, a short working 9 heads back towards St Helens. This was the halfway point on the circle. In the background, part of a loop, which also doubled as a Y. A non-stop procession of buses passed through Prescot en route to Liverpool. Liverpool's trams at last served Prescot in June 1949. Once, many years previously, it had been possible to travel by tram all the way to the foothills of the Pennines. Heading back to St Helens, a clockwise 7 passes the King's Head, demolished in the 80s. This part of St Helens Road, with bracket arms on either side, now forms part of the Prescot bypass. Most of these green spaces north of Portico are now filled with houses. Beecham's clock tower dominates the horizon on the way into town. Public service would end on the 30th of June 1958, by which time the swift, silent trolleybuses looked shabby and soiled.
Looks like a rugby scrum in the street. Girls and boys, men and women, whole families, all scrabbling on the ground for money thrown from Prescot Town Hall. The year is 1927. The scrum is actually parrying, an old tradition brought back to life through rediscovered, restored film archive.
We don't know whether it was a custom that went on throughout Merseyside. All we know was that these hot pennies were thrown from the windows of the town hall and gathered by the children in the streets below. It's very exciting, obviously something we knew very little about and hope that people can tell us more about so that we can share it with the people around the region.
Louisa Green from Widnes thinks she can fill in the gaps. She's 97 and vividly remembers taking part in parrying in Prescot before 1927. She says the pennies were thrown by councillors on Maundy Thursday, but they weren't hot.
We used to hurry from school, we'd all wait and we'd be shouting, open your window, throw your money out. And we should try and get the money from off the floor. The lads would run at us and pull the foot on us, on our hand. You know, try and get it off us.
The film was found here in the projector room of what used to be Birkenhead Town Hall. It's now Wirral Museum. It was unlabelled, and staff here couldn't have known that such an important piece of history was right under their noses.
It does put a tingle of excitement because it puts you in touch with the past, and that's what museums and archives are all about. It's actually bringing things alive.
The parrying ceremony is not the only old footage to have been found. This film shows people selected for jury service enjoying a glass of ale. And this is the Crosby Carnival of 1947, complete with fantastic floats, fancy dress and carnival queens. The restored films will now be aired around Merseyside, starting in Birkenhead, so everyone can enjoy a glimpse of the past. Abby Jones, North West Tonight, Wirral.
Well, amazing footage, wasn't it? And it's brought back a few memories for you after we showed it at lunchtime. Frances Etheridge contacted us saying that as a young girl in Barrow in the 30s, she'd arrive outside a wedding and shout, "Scabby wedding," until the bridegroom threw pennies out of the window. Simon grew up in Northumberland and remembers that at weddings, children would be thrown hot pennies to distract them and stop them playing tricks on the bride and bridegroom. Howard Neve from St Helens says he believes that parrying had something to do with the meeting of the Court Lee, which was a kind of early town council. Mr Pearce from North Wales says that when cup finals were played, children watched the coaches setting off from London to Wembley, and kids shouted, "Chuck out your mouldies," whereupon coins were thrown from the coaches. Might try that when your team's playing away next.
Hello and welcome to a Prescotian's Guide to Prescot. As you are about to see, Prescot has a long and fascinating history. This film is dedicated to all Prescotians, both past and present, who made this town what it is today. Prescot stands proudly between the townships of Liverpool and St Helens, a place which Prescotians take pride and visitors take pleasure. In 1445, Henry VI granted it to the College of St Mary and St Nicholas, which later became King's College, Cambridge. As Cambridge was so far away, they appointed the Derby family to oversee the running of the manor. So began a long association between the Derbys and the people of Prescot. One of the privileges that the people of Prescot enjoyed as tenants of King's College was the right to their own court, known as the Court Leet, which was embodied in the Prescot Charter of 1447. Prescot also adopted King's College, Cambridge's coat of arms. This one is above 8 Vicarage Place and was taken from the old town hall. Of course, the focal point of the town has always been the Church of St Mary. The church is the fourth to occupy the site since the 11th century. The dedications of the older buildings were to All Saints, but after the reconstruction of 1610, the church was dedicated to St Mary the Virgin. The church has a number of interesting features. I'd like to introduce Jessie to tell you about some of them.
The arms box is an interesting old box, but we haven't got a date for this, but it is very old, probably at the time of building the church, or may even have been from the previous church. We're not sure at all about that. But the figure here is of John Ogle, and John Ogle was the Lord of the Manor of Weston. He had a great deal to do with this church and a lot to do with the building of this chancel. He died in 1612, and he was one of the men of the Crusades, fought at the Crusades, and was a very wealthy and noble man of the time. The dress is Puritan style. This font is Italian marble font, and it was given by the Willises of Horseneed in 1755. And this is where John Kemble, the playwright, was baptised in the 17th century. But it is Italian marble. And it was at the back of the church, but it is used more now at the front here so that everybody can see. We are now in the belfry where the famous 8 bells were always rung. Sadly today they're not rung. But this here is a plaque in memory of Walter C. Finney, who rang the church bells here for 61 years. He was my grandfather, and this is the photograph of the bell ringers, the last bell ringers, and this is Mr. Finney, my grandfather. The other photograph here is of an older group, but Mr. Finney is still on there as well.
Here we have a scene from the 1950s. This map shows the Elizabethan town, a century or so after the end of the medieval period. This is the earliest known map of Prescot. The circular nature of the churchyard is a strong indication of a Celtic settlement. Fall Lane is now High Street. Newgate Street is now Eccleston Street. Sparrow Lane is now Grosvenor Road. In 1592, the marketplace was the focus of the town's trade and civic life. Copholt Lane is now Kemble Street. Prescot collieries had existed since 1723, the earliest commercial coal mining being carried out on the Prescot estate to the south of the town. Some of the coal was transported in carts and sold in Liverpool. To make transportation easier, the road was turnpiked in 1726. We now come to Our Lady Immaculate and St Joseph R.C. Church. It is a Victorian church in the Gothic style, built of red sandstone in 1856 by J.A. Hanson, inventor of the Hanson cab, and students of architecture from Cambridge University regularly visit Prescot to inspect his work. The main street in Prescot for centuries has been Eccleston Street. Here we have a glimpse of it in the 1950s. There have been a number of changes since then. Eccleston Street was formerly known as Newgate Street and Fountain Street. The latter probably because of the regular flooding of the cellars along its length. Prescot has had two cinemas in the town. Here's the old Limehouse Cinema, which was opened in 1922. It was a grand ornate theatre. It was at its peak in the 1930s and 40s. Unfortunately, with the introduction of the TV, its popularity declined, and it followed the same route as others around the country, i.e. it was turned into a supermarket. Legend has it that the cannons outside the Dean's house came from Nelson's flagship Victory, and that Captain Hardy once lived for a time in a house at the corner of Mill Street. Here's the original site of the cenotaph, before it was moved to its present site in the church grounds. In 1811, a roundhouse was built, round the base of which country folk placed their baskets of butter and eggs, etc., on market days. In 1859, however, this and the stocks nearby were pulled down, and a market hall was built to provide a regular indoor market. It too has long been demolished. This is the old town hall, built in 1755. It provided accommodation for the court leet on the first floor and the shops underneath. It unfortunately fell into a bad state of disrepair and was demolished in the 1960s, despite efforts from various local groups to get it preserved. Here we have the Wesleyan Methodist Church, built in 1909. It is said that the great John Wesley preached in Prescot in 1768. This is the Flat Iron House, so called because of its peculiar shape. It was built in 1890 for use by the Lancashire Watch Company. It is also believed that this was the site of Prescot Playhouse Theatre, built in the late 1500s. The Lancashire Watch Company was set up in 1889 in Albany Road, because the traditional cottage workshops could not compete with the fierce competition of Switzerland and America. It was a major employer at the time. It operated until 1910. The building was also used as barracks during the First World War. Also, Tinglings, the printing and bookbinding organisation, operated here until the 1970s. Prescot Grammar School, or Free School, was founded in 1544 through a bequest being made by Gilbert Latham, Archdeacon of Man. The first school was sited in Church Street. It moved to High Street in 1759. In the 1920s, the school acquired part of the Yew Tree Farm estate, St Helens Road, from the Earl of Derby. The new building was opened in 1924. It went co-educational in 1975, when it amalgamated with the Girls' Grammar School. The Royal Hotel used to stand on the site next to where Croxford's Dental Surgery is now based. It is said that it was also used for stabling when the hotel was a coaching station. It closed in 1930. Prescot has had its own paper from way back in 1859, when the Prescot Reporter and General Advertiser was first published. It cost a penny for 4 pages. The club was founded in 1884 by members of Prescot Cricket Club, whose ground they shared at Slacky Brew, Warrington Road, until 1903. Then a dispute developed. They had to find new premises, which they did in 1906 at Hope Street. In 1929, they became Prescot Cables, in recognition of the support by the local BICC cable making organisation. Some notable players who went on to bigger things: Jack Bamber of Liverpool and Leicester, and Eddie Kiltshaw of Bury, Sheffield Wednesday, and Derek Hennin, who won an FA Cup winners' medal with Bolton Wanderers in 1958 against Manchester United. The first tram line was opened in Prescot in 1902. Here we have a scene from the 1950s showing the old King's Arms and Edwards's. The King's Arms was demolished in the 1970s and replaced by the Fusilier. The Royal Oak car park area was the site of Garth's Car Mill around about 1908. Here we have the council offices in the 1950s. They were built on the site of Zackley House, a Georgian building owned by the Evans family. We are now in the passageway known as the Poorhouse Wings, probably so called because of Prescot's connection in being one of the first parishes to provide houses and poor relief for its inhabitants, as parishes were supposed to have done under the Poor Law of 1601. By far the biggest contributor to the shaping of Prescot, and indeed many outlying towns, is of course the British insulated Calendars cables of the good old BI. At its peak it employed something like 8,000 people. James and Jacob Atherton founded the company in 1890. They acquired the British rights to an American patent for paper insulated telephone and electrical power cables for use in lighting, driving machinery and tramways, etc. They became self-contained with their own copper and aluminium mills, wire drawing and cable making plants. They also had their own foundries.
2 miles from Prescot is the Highton Quarry factory of the BI, where enamelled wire is made. The wire has first to be wound onto special reels in preparation for the enamelling machines. The enamel is applied by passing the wire through a bath and then an oven of closely regulated temperature, which bakes the enamel to a tough and elastic consistency. The process of immersing and baking the wire is repeated several times until a coating of enamel of adequate thickness is built up for the purpose to which the wire will be put. The enamel used has extraordinary qualities as an insulator, and in nearly all cases is the only insulation with which the wire is provided. It will stand, without deterioration, temperatures which would destroy insulation of a fibrous character. Enamelled wires are used almost exclusively where the space factor is of importance, as in telephone receivers, wireless apparatus. We are now in the Helsby Works near Warrington, where rubber insulating and covering is done. The conductors of rubber insulated wires and cables are of tinned copper and may be single wires, strands or bunches of wires. The machines here are making strands of various numbers. With stranding, as you have seen, the reels holding the single wires are rotated in the machine. When wires are bunched, however, the spools of fine wire are fixed on a frame, and the reel on which the completed bunch is wound is rotated at very high speed. Now let us turn to the preparation of the rubber used for insulating. It is of vital importance that the raw crepe rubber shall be absolutely clean, and great precautions are taken to ensure this. The raw rubber with various powders is mixed on mills with steam-heated rollers. After the mixing, the rubber is calendered into thin sheets, which are wound up between calico to prevent the layers sticking together whilst yet warm. Next, these sheets of rubber are cut into strips, ready for the covering machines. This is the rubber covering shop, where wires and cables of all sorts and sizes are covered with rubber. Method of covering is what is known as longitudinal. In this machine, 24 tinned copper wires or small strands are led from their reels into a flat band which passes into the machine with a strip of rubber compound above and below it and is fed through accurate grooved rolls which, acting by crushing and cutting the rubber, surround each conductor with a layer of the compound with a perfect seam on each side. According to the thicknesses of rubber required, this process can be repeated. As a general rule, 3 such layers are applied. This process is applicable to single wires and conductors which are not large in diameter. When larger strands are to be covered, the rubber compound in strips of the required thickness and width is lapped on the conductor. In this big machine, 5 such layers are being applied at the same time. These larger cables are used for main cables for motors and transformers and for service cables. Another type of cable, used for instance for house wiring, is covered with a tough rubber sheath. This tough rubber sheath, without seam, is extruded by pressure over the cable. The girls are laying rubber cable in the tray, ready for vulcanizing. After vulcanization, tough rubber sheath cables have the maker's name and grade of cable printed on the surface. All rubber insulated cables are tested in water in which they have been immersed for 24 hours. They are first subjected to a straining voltage, several times that at which they are intended to work. Some cables, as you have seen, are tough rubber sheathed, while others are braided and compounded. Another type of finish consists of lead or alloy sheathing. The molten metal is charged to a lead press, which extrudes the lead or alloy under great pressure round the cable in the form of a seamless tube. Motor car cables are provided with several different finishes, and one of the most common is an armouring of a spiral of bright aluminium wire. Most of the conductors you have seen are made of copper. In order to provide the exceptional flexibility required by telephone instrument cords, the conductors you see here are made of tinsel. Other machines are covering very fine wires with a layer of the purest quality silk. In some cases, wires so small as 1/1000th of an inch in diameter are covered. Before cables are dispatched from the works, they are wound onto suitable drums. Here is the alloy sheathed house wire being automatically measured and cut into 100-yard lengths. Such a large and varied output of cables and wires receives ample evidence in the finished material stores, where large stocks are kept ready for immediate dispatch to any part of this country or abroad. From the stores, the goods are conveyed to the adjoining railway station by our own narrow gauge railway.